Hello and welcome to the November 1st, 2017 edition of the Cluster API breakout meeting for sig-cluster Lifecycle. We're going to start today with just a quick PSA I've got that tomorrow at 1 p.m. Pacific, I'll be presenting sort of the current status and direction of the Cluster API to sig-cluster-ops. Rob, the lead of sig-cluster-ops, has put out a couple of announcements about this. He announced it in the community meeting last Thursday. I know he sent out an email to the sig-cluster-ops group, maybe the wider Kubernetes dev group, to help sort of collect operators, as we're looking at that as a good forum to get feedback in terms of what sort of requirements we should be looking for the Cluster API. I think I mentioned last week, we have a sort of set of requirements that we as Googlers have garnered from our experience operating Kubernetes clusters for GKE, but we feel like that there's obviously stuff that we're missing from the way other people run their clusters, and we're hoping to sort of collect as many use cases as we can from the community to help drive this effort forward. So just a quick announcement there. Next, I'm going to toss it over to Jacob to give a quick update on where we are on the Machines API. Last week we had a lively discussion about the current PR for the API, and I think we've made some progress since then. So Jacob can give us an update on where we're at.
Sure. So the PR is still open. It's received more feedback that I've addressed. Nothing's actually changed in the API so far. The types have been merged to the kubedeploy codebase so that we can start prototyping on them. They've been integrated with API machinery, and we've generated deep copy functions and all that. So we actually have prototype machine controllers that work against it. We actually have one pretty fully functioning for GCE right now. We also have a GCE installer, which hasn't really been bridged all the way to meet the machines controller, but we're bringing that together now. But so we're calling it V1 Alpha 1. It's not actually set in stone V1 Alpha 1. Still welcome more feedback on the PR. And there's actually a few issues that come up on the PR that I was hoping we could talk through if there are interested parties here. That's kind of the status right now. I don't think anyone's prepared a demo like we did last week, although last week's demo wasn't really prepared, but we have a more functional GC machines controller to figure out any edge cases that we missed or anything that wasn't well supported in the API. And so far, we've figured out kind of the nuances of what the expectations of different components would be, but nothing's actually broken the API. So maybe one of the things that we could talk about this meeting or next meeting is internally, the Googlers that have been working on the GC prototype have kind of figured out, here are the responsibilities of the installer. It should only do these things, and by the time the installer finishes, all of these things should be met. Whatever controller is handling the machines has these responsibilities, that sort of who's in charge of what kind of at the high level architecture. But everything with the API as stated has been working right now, although we haven't really talked about the cluster level control plane API. We've only been talking about the machines API. But one of the things that's come up in the PR and actually came up on earlier drafts of the doc was how to differentiate different kinds of machines. Originally, way back when, my very, very first draft had just a single string that said, like, are you a master? Are you a node? I got very early feedback that that was very inflexible and would probably have a lot more roles in the future. So it should at least be a list of strings. But we haven't really nailed down all of the different out-of-the-gate configurations we want to support. Last week or a few meetings ago, someone even brought up, what if I want a machine that only runs etcd? I just want to bring up an etcd cluster. So I think at the very least, we want to be able to differentiate between a machine that should just install the kubelets and register with them with current masters versus actually install the control plane. But I'm wondering if anyone has other thoughts of things they want to get in, like absolutely in the V1 Alpha 1 this quarter, we should be able to represent these other configurations. Because some of the things that I was rat holing on were, what if you want a master that is unschedulable, or what if you want to differentiate between a master that should have worker or workloads on it, those sorts of things. So I'll stop talking. Does anyone have any thoughts on that? Or on the representation of these different roles, which right now is...
So config of clusters is generally pretty hard. Like we have to today go download the flannel YAML file and tweak the default IP ranges because they just happen to sit on our corporate network already. So it may be hard to cram in all of those settings somehow into the Node API. The other thing that we've run into a lot is depending on which distro you're deploying with, you might have to partition your drives in different ways. So you can use a different Docker volume backend. It can get really, really messy quickly. So having some kind of abstraction in there where you can tell it, a really high level, I want this kind of thing, and then you have some kind of provisioners that us operators can tweak as needed. So if we need to override things or change partitioning or whatever is necessary, in particular, bare metal hardware is really messy and often needs very customized settings to get to work. Have the API abstract enough that you can choose the type of provisioner that you need, and it's flexible enough in order to do what the operators need to do.
Sure. So the way that we've gone after this so far is at the top level of the Machines API, we have common fields that we think you would want to be able to actuate over time, independent of the exact cluster configuration and environment in cloud and whether you're bare metal or anything like that. So the things that are common in the spec are what is the version of kubelet, like really coarse grain. What is your container runtime? Things that we think, regardless of environment that you're in, you might want to write tooling to say, oh, I want to upgrade this node, or yeah, that sort of thing. But we also have this completely opaque provider-specific blob that you're allowed to put whatever you want in, as long as like each different provider. And in this case, we're prototyping for GCE, so we have this other API type that is just for GCE. It's GCE provider config that has all of the information that we need to create a GCE node and anything else we want to shove in there. And that lets us fiddle with all of the little bits to get things just perfect, but it's completely unportable. But that means that we still get that level of flexibility that we want out of our specific installation, but then we can still write tooling on top of the cluster API that is completely cloud agnostic and can still do things like upgrade a node, upgrade the control plane, those sorts of things. Does that kind of address your concerns, or do you think?
I think that mostly does. Would there be kind of a multi-scheduler kind of support like there is in pods? So like if you could potentially run GCE provisioner and a bare metal provisioner in the same Kubernetes, and you tag your node types as I want it to be provisioned by this kind of tooling.
Yeah,
that might work around it.
So maybe this is wrong, but instead of calling out a specific provisioner equals this field, we've relied on the fact that when you, the information that you put into this blob, this provider config, should be a serialized API type with a proper kind. So if you set the kind to be GCE node or GCE node config or something like that, then only the GCE machines controller will pay attention to those machines. And then you can also have your config be local bare metal config or something like that. And you can have two different controllers that are just watching two different kinds. Now that kind of forbids you from saying, I want to use the same type and have it actuated on by two different controllers. So maybe we do want to call out explicitly the provisioner. But that's how we've been thinking about it so far. Like every machine object that's housed in the cluster should be operated on by that cluster, but you can run different specialized controllers that handle different kinds based off of the provider config.
Yeah, I mean, that kind of sounds similar to the way Ingress does things, where you have Ingress classes and you annotate your ingresses with it.
Yeah, we've been careful to stay away from the annotations portion of Ingress, but it's certainly like you have these generic objects and then you run your provider specific controller that knows how to actuate them in your specific cloud.
I'm just trying to make sure that we don't run into the case where we have like now where there's one cloud controller and you can't have two different clouds pointed at.
Oh, I completely agree. And in fact, like even in kind of some of the straw man examples I was thinking of is even in GCE, you might want a generic node controller for generic workloads, and then you might want a highly specialized, if you're doing machine learning, a completely different controller that understands GPU nodes and how to scale those and
exactly.
policy. And you don't want to scale them down ever, but you want to keep it at like a fixed state. So yeah, even in the same cloud, you could run multiple controllers to handle different kinds of machines.
Yeah, that sounds good.
And I'm wondering, to me, that seems like a more valuable use case. Like on bare metal, you might have two controllers for two different types of hardware or something. And on GCP, you might have two different kinds of controllers for two different types of machines you want to manage. Do you have a use case where you actually want a cluster to have two different controllers because you have bare metal nodes and GCP nodes in the same cluster? Or you're just worried about a situation where you might need different control over different types of things, even when they're sort of co-located in space?
So I could see some like auto scaling functionality just sitting on top of the Node API, and then you might want it to try to request bare metal nodes until you don't have any more, and then keep going out to a public cloud.
I think actually that's an interesting, like bringing up autoscaler is interesting because I know that in the node autoscaler, whichever one that's called, I can't remember, but there's a problem in when you're trying to choose like how to expand a node. You want to know, when you're planning an autoscaling group on AWS, for example, you want to know the labels and the taints which the nodes will come up with, and that is sort of tricky. And if the machines had the labels and taints that the node will come up with in there, or at least some subset of them, that would help the autoscaler do that. And I'm wondering if that same list of labels should also, I mean, we already have a label, controversially, for the role. So that same role could also trigger, the logic in the provisioner controller, whatever we're calling that, to say I am a master, or I am a node, or I am a OpenShift ingress, or I am a pure etcd, or whatever it is. Or maybe even I'm a bare metal, but that's a whole separate kind of worms. The very focused one. How about we use labels?
Right. So if we use labels, we'll have to sort of hard code special knowledge about a couple of those labels, right? Like the master label in particular has implications because like we don't just put a master label on machines, we also put master taints, right? And so if you put one but not the other, sort of what happens?
Well, I don't know that we have to hard code it. What I'm thinking is that the machine API wouldn't really care. The controller, the node controller, the machine controller would obviously understand those and would have knowledge of them, but like COPS has knowledge of them already, GKE has knowledge of them already. In other words, like acting on them happens. But the autoscaler wouldn't necessarily particularly need to know either. It would just see, in the brave new world where we separate out etcd, my masters are under a lot of CPU pressure, let's scale them out. Or my nodes are under CPU pressure, or my GPU nodes are under GPU pressure, or whatever it is, right? So it also is agnostic, but it wouldn't say, my masters are under pressure, I'm going to scale out this random GPU pool.
Yeah, I guess what I was saying is that if the autoscaler needs to know if I provision a VM and it shows up with these labels and taints, if the master specifies a role as a label, but doesn't also specify the taints, that's not going to be enough for the autoscaler to understand that when I create a new one, the controller knows that label implies all of these other things, that will also be added to the node. The autoscaler won't have that same knowledge. And so it'll say, like, I'm going to try to spin up a new master, but if I create that VM, it'll have the role master, but doesn't have all the taints. I need to actually schedule another API server. So that's not going to help. Therefore, I'm not going to do it.
Yeah, so you kind of need one level of indirection maybe where the autoscaler asks for a node of type, GPU node, and the provisioner takes that and says, he wants a GPU node. It needs to have these taints and these tolerations and these attributes and whatever, and then go to the cloud that it's going to need to be on and go launch it.
I mean, if the machine had the set of labels and the set of annotations, would that not work?
I mean, if it has all the labels and taints that will show up when provisioned node shows up. I mean, one sort of higher level discussion to have is, we'd spent quite a bit of time talking to the autoscaler team to figure out what they would need to make the autoscaler work on top of the cluster API. And it complicates the cluster API quite a bit because there's a lot more that the autoscaler needs to be able to do things automatically than a person would need to do things manually. And so we've talked about sort of scaling back the initial implementation to make things work really well for a person, and then layering on the complexity later to make it also work for the autoscaler, and trying to make the person-oriented interface much simpler as a result, to make it easier for operators to use themselves, because operators will understand a lot of these things just sort of implicitly using the system. But the autoscaler needs to have very explicitly to work, right?
But we don't want to have a human-focused field, which, like, we don't want to have two answers for how we specify I am a master versus a node, right?
That is true. We do not want two answers for that. But in terms of things like the indirection between labels and taints and how the autoscaler automatically knows that those will show up on a node, like maybe that can be a more complex set of objects than we want to express just for a user. Right? Like, so we've heard feedback that the more objects you create, the harder it is for users to use the system. So if you have the initial proposal, we'd have templates and classes and machines and these relationships between them, and that was sort of designed so that the autoscaler could work. But for a person, that becomes very complicated because a person now needs to understand how to construct 3 different objects with all of the right cross references to actually tell the system to provision a node. Whereas if a person can just say, give me a new machine, it should look like X, then that's much easier for a person to do to provision a node, but maybe isn't sufficient for the autoscaler. And so for the autoscaler, we might need to introduce a couple of extra things to make the autoscaler work, but those aren't actually necessary for the system to work for a person.
Yeah, I guess strictly for like public clouds, the API is probably so static that the user doesn't necessarily ever have to template that stuff out. So they could just, Helm install provisioner or something and it would just work. Whereas for bare metal folks, they're almost always going to have to tweak those things, I think.
Yeah, but if you can create a template where you sort of tweaked all these things and said, like, here's the template of how to run, what my bare metal machine should look like, and you have a corresponding controller that can take that template and provision bare metal machines. The question was, is that enough, or do you need more levels of indirection? So I think for the autoscaler, we maybe do need another level of indirection where we abstract the common fields that the autoscaler cares about, as we've said, to know what the new machine will look like in terms of being able to schedule pending pods. But a human doesn't need that extra level of indirection.
Okay, so here's a question: the Kubernetes doesn't exactly have a concept of multi-tenancy yet, but it may. Is this something that non-cluster admin users are going to want to do? And if so, is something like a flavor where admins create flavors and users consume them, would that indirection be helpful?
In terms of, like, you could specify like an RBAC rule saying, like, I've created a template and this team in my company has access to create more machines of that template, but the other team doesn't. Is that what you're saying?
Yeah, possibly, and or that gives Kubernetes operators the chance of tagging things onto the flavor that then users don't have to bother with anymore. So you can say, I want a big compute versus a small compute, and then users just can choose from those things and not have to worry about, how many gigs of RAM is that,
So in an earlier draft of the proposal, as Robert alluded to, there were these notions of machine classes and machine templates. And I still think that in the future, there might be need for them to do exactly what you said, to say, I just want a machine, but instead of providing this enormous blob that fully specifies exactly how to create that machine with all of my cloud-specific bits. I just want to say class equals large or class equals GPU, something like that. And I just have a vague notion. The argument against it, I'm just repeating what Robert said, like there was some pushback against introducing so many concepts all at the same time. And so I think the logic goes, if we at least need the ability to fully specify an entire machine on its own, which we think is a powerful concept for human or someone who is just getting started, to say, here's a machine, create it. I don't have to create like 3 different objects and link them all together. So if we just want to at least be able to specify that, then we could start with that base and then always add on the concept of like a registry of templates, which we were calling classes, a machine class, that would then basically take that provider blob, the provider config, and just have as many objects as you want to with different names. Then you could just specify each name, and it would still be backwards compatible, and you could still maybe override certain fields from it. We would just merge, here's what I got from the template, and here's what you additionally specified in the individual machine, and we just kind of merge it on top of it. But we can start with just the simple machine and get that API out there, and then always add more complexity in the future.
So kind of following the path that PVs took, where you just had to create them very specifically, and then later on they added dynamic PV creation and storage classes, and yeah, that makes sense.
Cool. Yeah, and I don't want anyone to take like the takeaway to be that we're never going to go in that direction. Like I actually think that was a really strong direction to go into. It's just we really want to start as absolutely minimalistic as possible while still delivering some value and showing the vision, and then hopefully incrementally execute on that vision.
Mm-hmm.
The feedback we keep getting was Kubernetes did not start with replica sets and deployments, even though we take them for granted today. Like they just started with pods and really made sure that we understood pods before adding all of the other things on top of it.
Mm-hmm. And that makes sense.
I think your analogy to volumes is also apt, because we didn't start with persistent volume claims and dynamic volume provisioning. We started with the simpler, like I want to mount this volume, and right, and then graduated towards the more complex scenarios. Whereas we started with our API looking at the more complex scenarios, saying like here's a cool way to do it, and I think that extra complexity from the start is maybe not necessary or warranted.
Yeah, that makes sense.
I actually want to throw out a pretty maybe controversial idea. So I was brainstorming with Chris Rousey, who's on the call last week, and he's been really focused on the control plane level definition of the cluster API, whereas I've been looking at the machines level. And one of the things that he brought up actually was if you want to enable the tooling to be written to allow you to upgrade a cluster, if you completely separate out, here's the definition of my control plane and the versions of the different components that I'm running versus the machines, and some of those machines are masters, flipping one bit on the control plane doesn't give you a lot of control over like a slow, steady rollout of the masters. So another potential way of representing masters is to have a separate master machine or something like that looks almost identical to the normal machines, which are meant to be nodes, except it allows for additional pointers and configuration to say, here is, either it's an object ref or something to say, here is the version of the control plane configuration that I want, so that someone writing tooling on top of this could actually say, upgrade just that master, or upgrade the control plane just on that master, upgrade the API server on that master, wait for it to be successful, then I'll go to the next master, upgrade that API server. Whereas right now, if they're completely separated, you just upgrade the entire control plane all at once if your tooling sitting above the cluster API. So is that a completely crazy idea to have additional fields in master machines just to keep track of all of the control plane snapshot version?
Just quickly on that, I don't know if I would go so far as to separate out the type, maybe just add fields to the current machine type that are optional and only valid for a master role, but that's generally what we discussed.
And let me throw in the other crazy wrinkle. And looking at what KubeADM is doing and BootCube and friends, they're using Kubernetes to manage Kubernetes control planes just like there are any other things. Is there really much need to have an actual controller node type versus a non-controller node type when you're fully self-hosting everything?
So once you've gotten past the bootstrap stage, I don't think so, although they probably still have different taints and labels for the master. But for bootstrapping, it's somewhat critical to say I need to bring up at least one machine where I manually install the control plane, or whatever the startup script knows to do kubadmin init versus kubadmin join or something like that. Like at bootstrapping, it's at least critical to know, do I need to install the control plane versus am I just joining an existing control plane?
I think there are other issues at play with masters as well, because if you're bringing up like an HA scenario, you need to like modify its flags to know that they're now pairing with a different set, and it's a little more complicated than just, hey, turn on this node. There's other information that has to be brought in.
Yeah, and that's what things like etcd operator and they're building that kind of logic in there. I'm just wondering, if this machine API is sitting on top of Kubernetes.
I think you cut out there. Did anyone else hear him?
I can't hear Kevin anymore. He cut out.
Justin, did you want to jump in?
Yeah, I just wanted to ask, my understanding is you're talking about basically versioning the version of other objects that we're referring to, I guess. I guess if that's the case, I don't understand why this problem is specific to the master nodes. Like, to me, it applies to every node and also to every object in Kubernetes, right? That references another object.
Oh, so right now, the machine object has inlined the configuration for all the things that we think are specific to that machine. So like the version of kubelet, the container runtime to use, the version of that. But it has no concept currently of the control plane. And we're saying there's this separate object called the cluster object, which has all of the configuration of all of the control plane components that we care to represent in the API. But right now, there's actually no link between the two. They're just Ajit jumped in. They exist simultaneously, but there's no explicit link. So, I mean, if we need to throw in an object reference or something like that, so that if that gives us versioning control. But from a use case perspective, what I'm putting forward is, do we need to support the tooling to be able to only upgrade the entire control plane all at once? Or do we want tooling built on top of the cluster API to have the fine-grained control of upgrading individual components on individual master hosts? And how we achieve that technically is a separate problem, but is that useful?
I guess I'm saying that the kubeadm folks are trying to, or at least the bootkube folks are trying to do it entirely self-hosted. So you use Kubernetes pods and deployments and things to do your rolling upgrades. So there's already another team working on exactly that problem. I'm not sure that the machine API needs to tackle that.
I think the bootkube and kubeadm people have the ability to be very opinionated about how you deploy. But say your provider did not want to do self-hosted. They wanted to do another installation or hosted method. I think we should be able to allow a provider, if they want to do that, get versions from the cluster API and say, oh, okay, I need to upgrade this master this way and go do that. Now, if you want a self-hosted cluster and they want to use kubeadm to upgrade that, perfect. But I don't think that's a reason not to at least explore the ability to.
Yeah, I guess what I'm saying is having like annotations like kubelet version or controller API server version or whatever, having them hard-coded and have some special controller types and things be baked into the system for that use case. I don't think we need to do that. I think we can have kind of more generic key value kind of things, and if they want to not self-host in Kubernetes and load a provisioner that does the orchestration and reads some key value pairs that they define as being needed for their particular process. It would allow folks that want to self-host to not have to carry a whole nother parallel set of machinery to do that, and those that don't want to use self-hosted can load a machine provisioner that has that logic in it.
Yeah, but the whole value of exposing this is to now allow a generic tool to be able to say, I want to upgrade all the masters in this cluster, and give them a generic way to do it, not a abstract key value pair way of accessing it. Does that make sense?
But on the other hand, that's baking in the assumption that the machine API should be able to drive upgrades of the cluster, and in a self-hosted environment, that's probably not the right place to do it, I think.
So in the self-hosted environment, we use Kubernetes to drive upgrades of the Kubernetes control plane.
Yes.
But nobody has yet used that to drive upgrades of the kubelets, although the CoreOS folks are working towards that. But also there's the underlying operating system. So
yes,
even if you're using Kubernetes self-hosting to drive the control plane and the kubelet, somewhere you have to still specify upgrade CoreOS underneath those, or upgrade Ubuntu underneath those.
Yeah, I'm just arguing that I'm not sure that the notion of nodes are controllers or their computes necessarily makes sense for all use cases of the machine API.
Okay. So yeah, another way of looking at it is that the two different APIs, which we haven't deliberately separated very early on, could be useful and used completely independently. That you could say, I'm going to completely manage my control plane doing my own thing, but I'll use the machines API because I like the way this provisions machines and it works with these auto provisioners. And completely independent of that, I'm in bare metal, like I'm going to manually control my machines anyway. I don't really need this API, but I would still like to programmatically upgrade my control plane and all the configuration there. So maybe if we do keep them completely separate with, as Chris mentioned, maybe an optional pointer, if it makes sense, then maybe that makes sense. This might be an appropriate time to we're already talking about to dive into the control plane level configuration, which I think was next on the agenda anyway.
Yeah, we've already started talking about this, but the poorly planned out PR I put out started from the viewpoint of here's a cluster object that specifies the how you want to deploy a cluster, and a very minimalistic one. And I quickly started to realize that a lot of these aren't global values. They, like if you have more than one, like it's a global value if you only have one master in the cluster.
Right.
And so a lot of these needed to be split out into per master parameters. And we're discussing having a master role on machines. And the idea is that I need to rework this to move some of those parameters in some way to the machines API. I was hoping to do it by adding an optional field for master configuration to the machine if you had a role master. And that's where the current thought is, still leaving some of the global cluster configuration levels at the top level, like pod CIDRs and service CIDRs and stuff like that.
I guess I'm curious, Justin, how does COPS specify HA masters? Do you guys have individual records for each master, or is there just a single global thing that you sort of notionally say it applies equally to all masters?
We are fuzzy on this, and sort of like in the same way that config map, like that's why I think that like this is the same problem that we see with other things. So we will upgrade we'll put a new version of the configuration up there. We will then roll the masters we will force the roll of the masters in sequence, but they might like actually roll, like, the machines might all die and they might just all like randomly roll out of order. That is sort of the same problem that we have with config map today, I think, which is why I'm wondering whether, like a pointer would work well, where if we say, if you actually care, you can specify a pointer to a particular version of a cluster API object, and that will do it. And if you don't, then we can sort of infer it, or not infer it if COPS or the GKE version or whatever it is pairs. And if your tooling of choice, if your magical kubeadm doesn't care, then fine.
Yeah, I think that's kind of in line with dynamic kubelet config, where the node objects in the spec, they have a pointer to the config map, but you could just have one global config map that all of the nodes are pointing to, and as you introduce another one, slowly roll over each node to point at the new config map, and now everyone's pointing at the new one. Or you can maintain as many different ones as you find useful as an operator. So maybe the machine has an optional pointer, and if the pointer isn't set, we assume it's using the global control plane definition, but if it is set to a very specific thing, then we read that, and that allows us some flexibility there.
I guess the other thing to think about with masters is, I was chatting, I can't remember who I was chatting with about this, but the sort of official way you're supposed to upgrade HA masters is not knocking down one machine at a time. But it's, I think maybe it was Justin, but it's actually like upgrade all the API servers first across your machines, then upgrade all the controller managers across your machines, then upgrade the servers, right? So you're supposed to sort of horizontally upgrade each of your control plane pieces, not upgrade each machine to a new version. It's further complicated if you start tying the control plane definition to the machine. We are almost encoding sort of the quote wrong way to do HA upgrades.
Well, we're saying that it's a multi-stage process.
True.
You do the API and then you do your control manager and yeah.
So,
but at some point you also have to do the node, right? So at some point you have to do the OS in there somewhere, right? So at some point you do have to knock the machine over, but you should also be doing that, maybe the apps at a separate time than when you knock the machine over, which complicates things too, because then you have to qualify your apps on two different base images.
Right. That's a very good point.
So, to me, that suggests maybe finer grid control over the component versions instead of having just a control plane version, having an API server version versus a controller manager version at each machine level.
Well, not necessarily. Like, if we have, as Robert said, if we have just the right way of doing it and anything else, any deviation from that is the wrong way of doing it, then maybe we don't want to give that control where you can accidentally shoot yourself in the foot. So in thinking about all the levels of this API, I've been thinking about what is the amount of power we want to give to the tooling that sits above it, but also what is a really good user experience. And I think a really powerful user experience is I look at my control plane, which is 1.7, and I say, I now want you to be 1.8. And the controllers that are actuating underneath it just do it flawlessly. Like they know the exact perfect way to upgrade everything. And that's really powerful from a UX perspective. So the question is, do we then want the power to break that flow up for things above the control plane? That is based on the assumption that there is exactly one correct way to do this.
I mean, that's kind of the way what you're talking about is almost in a way what the operator concept is. Like if you look at Rook, they have an option in there when you spawn your cluster to say, I want a dual Ceph cluster. And then you can tweak that document and say, I want Luminous now. And it will look at the cluster and what you asked for, and it will do the rolling upgrade as appropriate for those particular versions even. The procedure might be different depending on which version you are on and what version you're going to. But they bake that logic outside of, they're driving the Kubernetes API to update deployments and tweaking config maps and doing whatever is appropriate to run the workflow. But it's a separate controller from how do you land a pod on a node. So maybe the workflow that you're talking about actually sits above the machine's API and drives it somehow.
Yeah, my one comment would be there should be exactly one way to do this until there's not, and you need to do something special.
Yeah, and well, we've already talked about two different ways of doing this too. The self-hosted way of launching your control plane and doing upgrades through tweaking the image in your deployments versus having node provisioners have logic in order to decide how to provision it. If it's doing it non-containerized or Puppet or Chef or whatever. That to me kind of follows kind of the ingress kind of style, where you declare what your cluster should be, and then you have an operator of some sort that takes in that declarative thing and through your chosen flow implements it. If you like Nginx or you like Traffic better, you choose which implementation you use to realize it.
I guess to echo, I think what's saying here. I mean, like, I think I made a sort of jokey comment, like that the way that it evolves is like we find problems, and that to me suggests that like we should bake that logic into code rather than have it be expect someone to like make the correct sequence of calls. But there are two places we can bake that into code. One of which is that the COPS provisioner, the GKE provisioner, all the machine or node provisioners would implement it themselves. That means we all write it and all get it right. And the other one is, I think, Kevin, what you were saying, where we have an operator concept that driven by yet another model, which pains me. Like, make the correct sequence of adjustments, and so the COPS controller is dumb, as the COPS controller should be. And the GKE controller is relatively dumb. It doesn't like have that knowledge of like, oh, I'm upgrading Kubernetes 1.8 and this has this weird flow where I have to like run this weird migration.
Well, no, I guess I'm arguing that maybe the COPS controller is two different types of controllers, one for managing the life cycle of the control plane and one for managing nodes or requesting resources. Maybe there's two parts to it rather than being one monolithic thing.
Yeah, and definitely. I mean, it's more just like, unless we find a magic project which we can all implement, which has yet to happen, like that we've all collaborated on one project, then we have to accept that however each project breaks it up, there will be like n implementations, and whether we want each one of them to implement the logic themselves or try to somehow have that upgrade logic be shared, which
Yeah, I mean, ideally, there's a shared upgrade flow, which is also what gets tested, and what we all test and throw our weight behind is saying this is how you safely upgrade your Kubernetes clusters. I think one problem we have today is like everybody implements their own upgrades, and we test some of them. We test some of them in different versions, and then we tell people that upgrades work.
Right. Yeah.
Which is dangerous, right? Because upgrades don't always work in every different configuration.
Yeah.
Yeah, I was reading the postmortem from I think it was Monzo, which was somewhat related to upgrade ordering, right? And so, if we had a canonical way to do upgrades, then maybe they wouldn't have gotten into the case where everything broke. They were running some extra custom software, so maybe that would have still broken. But at least the Kubernetes part of their system should have still maintained its function. We've also talked a lot with kubeadmin about having built-in versus external etcd. I think it's pretty common in bare metal scenarios to have etcd running outside of the cluster, having a separate etcd cluster you manage. And maybe in more cloud scenarios or in the sort of higher scenarios, you bake etcd into your cluster, right? So you run etcd on your nodes versus pointing to an external one. And so there's also some drift there in terms of how upgrades are going to work.
Kind of segueing into one of my next questions is, one of the comments on the PR was why there was no configuration for etcd, and I just wanted to throw this out there. Technically, etcd is an implementation detail, and I was wondering if we want to expose that in the official API. I mean, it's like a de facto standard, but technically you could use something else if you wrote the right storage interface.
I guess I'm arguing still that it should be generic enough that those implementation details should be able to be specified when needed. But it's kind of more back-end provisioners should figure out what meaning they need.
Yeah, I definitely think some form of etcd control should be available, but my main question is it do we want to make it generic enough that we expose it in an official cluster API, or we say shove it in somewhere like in the provider config or something that's generic?
I would suggest punting it until we need it. Like,
That's why it's not there right now.
yeah, like I feel like there's a recommended version of etcd for each Kubernetes version. There aren't that many flags which people want to tweak that often, although we had one come up in COPS the other day with like leader timeouts. But generally there aren't that many. People want to run it externally, will want to run it using the etcd controller, or the etcd operator will want to run it using like other ways. Like I think all the production users that are not using COPS and AWS have written their own like script, and it is very easy to do that. So
okay,
I think I'd love to see a project that actually like does a etcd operator that doesn't rely on Kubernetes. I think that would move us forwards a long way. But
yeah, and then coming back to another comment on my PR was the certificates that I had specified. I was only planning to expose like serving certs because I have a serious problem with putting private keys in the API. I have talked with some of the SIG-auth groups, and they're talking about moving the certificate signer off the master anyway, and that would have to require like an official signing API to be developed or something, so the master can generically call, hey, sign this blob for me. So I'm punting on certs for now and just delegating to the provider to, hey, sign the certs for the machines that you need to and distribute them how you need, but none of that is being stored in the API as of now. Does that seem like a reasonable approach? Do we want to let people specify a signing CA?
I'll say from COPS, it is easy to add things and very difficult to take things away. So unless anyone is screaming.
Yeah, I'm punting on it right now, and I was just wanting to know people's opinions when the time comes.
Do we have this isn't meant to be a leading question. So for the machines API, I just wrote out like, here are the 5 things we're going to support out of the gate, and there's just create a node, delete a node, update for these few fields, call out here are the things that we want to be cloud specific versus cloud agnostic. Do we have that either from you or Wes at this point of the scenarios we want to support for the control plane API for this quarter as like a V1 Alpha 1?
I don't think I've officially listed them, but my goals are create a master, upgrade a master, repair a master, and I guess delete a master, but that should be trivial.
Okay. But that doesn't really go into like the granularity of you should be able to support SKU API version and control manager version, or
yeah, it does not.
The questions you're asking, like, should we support etcd, seems like it should be easily answerable from this list of here's what's in, here's what's out. And etcd is clearly out because these are the only goals they're going after right now.
Yes. I was just wanting to get early feedback on maybe where we head with that goal to make sure we don't paint ourselves in a corner.
Absolutely. I just didn't know if that list exists yet.
I will make that formal when I update the PR. And also, since my PR may be updating some of the machine type, I'm going to base it off the part that you already have checked in because I can't really diff it off your PR.
Sounds good.
Okay. I'm going to mute myself because my dog's whining now.
All right, we have 6 minutes left, and the conversation has been dominated by a small number of people. I'm wondering if there are any other folks on the line that had opinions to express about either of these two topics, the machine API or the control plane API, other requirements that they think need to be included. Please don't be shy. You're here for a reason. Some people may just be lurking and listening, but we are here to get feedback from the broadest set of people that we can, even if they tend to be shy. So please speak up. Or type something in chat or into the meeting notes if you don't want to talk. That's fine too. Okay, so nobody's speaking up except Justin, who typed something in the chat asking what's next. So, I think on both of these fronts, we're sort of continuing to push forward. As Jacob mentioned earlier, we've started writing prototype code against the Machines API to actually try and get stuff stood up. And thanks, Chris. I'll see you soon. As Chris's PRs and types start to get merged, we'll start writing code against the control plane half to start setting up a master. A lot of this is really not to try and write production grade code yet. It's really to try and write code to prove out that the API makes sense and is usable and be demoable, right? So that's sort of the initial goal of what's next. Obviously, we're going to try to keep collecting feedback. I hope to get some feedback tomorrow in terms of requirements and use cases from sig-cluster-ops. And we'll sync up again in a week and hopefully have maybe some demoable stuff in a week from now. That would be the goal.
And does that mean like actually launching a machine on GCE AWS or something like that? Or
yeah. So we have a GC machines controller that actually starts and stops VMs. Right now, it just installs kubeadmin and kubelets, but doesn't actually do the init and join. But I think we're really close on that too.
And Chris has promised she's going to write something similar on Azure as well. Although I don't see her today, so it's hard to hold her to that promise.
And we have a cluster creator that doesn't currently install the machines controller. But as soon as we glue all these little pieces together that people have been working on in parallel, we should actually have a pretty reasonable end-to-end demo.
All right. Anything else before we take off? We have about 2 minutes left. People have one last thing to squeak in. All right. I'm hearing a lot of silence. So I think we're going to call it at this point. Thanks, everyone, for coming. And we will see you again in a week. And like I said, hopefully have something much closer or to a demo point. And feel free to follow along in the kubeadmin repo, the kube deploy repo. To see sort of the progress of the code and PRs in the meantime, or reach out to us on Slack. Thanks, everyone.
Thanks, guys.